Let's look at the definitions at the bottom of page 25. We have two terms we are defining. The first one is the center of a group. We say that the center of a group, denoted by Z of G, is a set of all elements in G that commute with every element in G. And so in set notation, we have Z of G is all elements in our group, so that element A, so those elements A, commute with everything that is in G. So AX is equal to XA for all X in G. So this is the center of a group. It's all elements that commute with every other element. So the center of a group is a subset defined via all things that are true about the elements in a group. The second definition sounds very similar, but it is a centralizer of an element of a group. So the centralizer of a group refers to the centralizer of an element. So we have to pick an element A first, and then the centralizer of this element A, denoted by C of A, is a set of all elements in G that commute just with that one element A. So in symbols, C of A is all elements in G such that GA is equal to AG. So again, they are connected but different. So a center is all elements in G that commute with every element in G, whereas the centralizer is a property of an element, or it's a subset just connected to an element A, and so it's just the elements in G, that commute with that one element A. It's probably easiest to visualize what's going on here by looking at an example. So let's look at exercise 2. Actually, before we do that, let me note one thing that's important. Both of these new subsets of G are subgroups of G. So both the centralizer and the center are subgroups. So the center, C of G, and the centralizer of elements are subgroups. Of whatever group G we are looking at. Okay, so let's look at an example. Let's look at D4. This is also exercise 2. I think it's part A. Yeah, it's part A of exercise 2. So here the group we're looking at is the group D4. It's a group of symmetries of a square. And we want to calculate the center of that group and then the centralizer of two elements, of R90 and of the vertical reflection. So let's look at what does the center of this group look like. And I'm not going to the page in the workbook that has that exercise because I want to look at the Cayley table for D4, and that is conveniently located right here. So I'm not working on this exercise, don't worry about that. I just want to have the Cayley table handy because this is really what we need to figure this out. So to find the center of G, we have to find the set of all elements in G that commute with every element in G. And let's look at the Cayley table and see if we can figure this out. Let's just go through one by one and see if we can see this. So R0, let's look at R0. Does R0 commute with everything else? And we talked about this when we looked at the Cayley table before. How do we see if something commutes with something else? We see it by symmetry. So we need to know, is R0 composed with anything equal to that anything composed with R0? That is the question. If the answer is yes, then R0 is in the center of our group. And so we need to compare the first row because that is R0 composed with everything, and compare with entries in the first column, because that is everything composed with R0. And we can see that very nicely. So R0 composed with R90 is R90 composed with R0. And then we can go down and compare the next two entries. And yep, R0 composed with R180 is the same as R180 composed with R0. And then we just go down, and yep, they are the same. When we compose with H is the same, with V is the same, with D, yep, that's the same, and so on. Those are all the same. So that means that R0 commutes with everything. So we have found something that is in the center of our group D4. Okay, let me do some cleanup, because next we are looking at our next group element. So now we are looking at R90. Let's see if R90 commutes with everything. So we need to compare the second row with the second column, and starts out okay. So we have R90, R90, okay, we have 180, we have R270, R270, R0, R0, looking good so far. D, D prime, oops, nope. Okay, since D and D prime are not equal to each other, we see that, what is that? H R90 is not the same as R90H. So we found something that doesn't commute with R90, so R90 is not in the center. So R0 was, R90 is not. Okay, next one, we can go through and see if what is happening with R180. Okay, what about R180? My color scheme is breaking down, but here we see, okay, so 180, 180, R270, R270, R90, R90, V, V, H, H, D, D, D prime, D prime, D, D. Okay, looks like R180 is in the center. All right, very good. I can do cleanup. And so you may want to pause the video and just check the other ones on your own. Let's look at, let's look at just one other thing. Let's look at H, because I don't want to go through all of them. Let's look at H. H, H. Actually, we already know that something was iffy with H, and because with R90 it didn't commute, right? So H, R90, and R90H were not equal to each other. So H is also not in there. And you will find that actually none of the other elements are in the center. R0 and R180 are the only ones. You can convince yourself that that is true by checking each and every one of them, but that is what you will find. So R270 is not in there, V is not in there, D is not in there, D prime is not in there. You will find something that does not commute with each of those elements. So the center of the group D4, so the center of our group D4 is just the set containing R0 and R180. So those are the two elements in D4 that commute with every other element. That is the center in our group of symmetries of the square. Okay, now let's look at C90. So we want to look at CR90. Sorry, I misspoke. So we need to find the centralizer of the rotation R90. And let me do some cleanup so that we can look at that again. And we already did a lot of the work, so hopefully this is not going to be that bad. We already went through R90 once and checked what all commuted. So we can totally see, oh, I need to fix that, sorry. R90 and R90. We are looking at the second row and the second column. And we already compared and found that R90, it commutes with itself. So it also commutes with R0. It also commutes with R270. We have the symmetry right here. Also commutes with R270, R180. Okay, what about it did not commute with H? We have different elements. It did not commute with V, different elements. Next ones are different too. And then last ones are different too. Okay, so it looks like only the rotations commute with our rotation R90. Let's note that down. So this is R0, R90, R180, and R270. So the centralizer of our rotation R90 are all the other rotations. All rotations, including R90 itself. Okay, so we got that. And now let's look at the centralizer of V. And I encourage you to stop the video and find it yourself first. I'm doing some more cleanup. Okay, so what do we got to do? We are only interested in our vertical reflection. So we are looking at V. How is V interacting with all the other elements in our group? Okay, V commutes with R0. It does not commute apparently with R90. It does commute with R180, it looks like, because H and H are the same right here. They both, V composed with R180 is H, and R180 composed with V is also H, so that one works. Okay, next one doesn't, not equal. Then, yep, those are equal. R0, that is okay. But then, different entries. Okay, so which ones did we find? We found that the centralizer of V is R0. What else? It's R180. And it also has H in it. And is there anything else? It also has V in it. V composed with V is V composed with V. So that element is in there anyway. But that's it. Those were the elements in the centralizer of V. Okay, I'm going to stop the video here. I'm going to make another one for part B of exercise 2, and then we can talk about this whole centralizer center business a little bit more.